We know.
Okay, we're going to talk about angles again, and this time they call it angle relationships. So I'm going to draw you a bunch of different pictures with lines and angles. You know how the angles, they have an endpoint and they have an arrow on the end? I'm not going to draw the arrow every single time. Is that all right? It just becomes a hassle. So I hope you don't get upset. Say what? Yeah, array. Yeah, array would normally have an arrow. Technically, it has an arrow at the end, but I'm just going to draw so many of these. I'm not going to worry about drawing the arrow. Don't do that. See, now you got me all not worried, but just cognizant of the fact that I say it. Okay. Here we go. Ready? Let's stop it. So let's call this 1 and 2. So this is angle 1. This is angle 2. There is a relationship between these. Check this out. This angle 1, this angle 2, they both share a couple things. What do they share? I just gave you a big hint right there, Alyssa. A vertex, and they also share, here's another big hint right here. Yeah, but yeah, it's a ray. It's a side, right? It's a side of the angle. They both share a vertex, and they both share a ray. Or I said ray, so she said ray. A side. Okay, they both share a vertex and a side. But there is also something else that's true about this. Let me give you the name of this relationship first, and then I'll talk about it. These are called adjacent angles. ADJ. ACENT. Adjacent. You ever hear anybody say that word just in normal conversation? Yes. Adjacent. Yeah. What does it basically mean in just a normal everyday language?
Next to.
Yeah, next to. You don't hear kids say it very often, but if you listen to adult conversations, every once in a while you might hear somebody say, "Oh yeah, my house is adjacent to Walmart," or my house is or that my room is adjacent to Mr. Barry's room or the bathroom or the gym or something like that. Okay, people say adjacent every once in a while, not a lot, but every once in a while. So it is a normal everyday word. Kids don't say it that often, but adults say it from time to time. So listen for it, and every time you hear adjacent, think, "Oh yeah, adjacent angles." Mr. Hamrick said I'd hear that every once in a while. All right, so anyway, let's do this. Adjacent angles. What are adjacent angles? Basically, adjacent angles are angles that are next to each other. It's kind of the easy way to think of it. But they do have to fulfill 3 different requirements. The first one, or the first 2, we've already discussed already. The first one, the 2 angles have to have a common, what do you think? Vertex. Okay, so they both have to have a common vertex, which means they share the same vertex. But we just say common. They have a common vertex, which means they share the same endpoints. Okay? Number 2. Okay. I know you're looking at me. All right. They have a common, what else? Side. We'll call it a side. Yeah, technically it's a ray, but they have a common side. Now the third one's a little bit weird. You might have not even thought about this at all. Let's go to a different color. Watch this. If I put a point in angle 1, that's in the interior. We talked about this the other day, didn't we? Interior and exterior. If I had a point in the interior of angle 1, could it also at the same time be in angle 2? That point right there, could it be in both of them? Could it be in angle 1 and also at the same time in angle 2?
Yes.
It could?
Could it be on the exterior?
I'm talking interior. Interior. Talking interior.
Angle 2 could be the 2 outside lines, and then angle 1 could be an outside line and an inside line.
No.
The way they're set up right now, let's not do all these ifs. The way that it's set up right now, is there any way that I could have a point that lies in both of them together? Somebody says, well, what about right there? That's in both of them. But it's not in the angle. It's not the interior in the angle. It's actually on the angle, isn't it? So I can't say that. So back to the question again. Can I have a point that lies in both of them at the same time? No, not one point. You say, well, I got a point here and a point here. Yeah, they're lying in both of them, but they're 2 different points though, aren't they? I'm talking about 1 point. No, you can't. So what we say here is we say, in order to be adjacent, you can have no common interior points. This is the hardest one for people to understand, but hopefully you will. Interior points. It means there's no common interior points. That means if I can have a point that lies in angle 1 and also in angle 2, then it's not adjacent. You say, well, show me an example of that. I like to see that. All right, I'm glad you asked. I'll show you one.
I'd like to see those.
I drew a picture in the last class. I don't know if I want to draw that same picture. Yeah, might as well. I'll just do this. Looks like the same thing, doesn't it? I'll even call it 1 and 2, but watch what I'm going to do on this one. Everybody watching? I'm going to call that big angle. You guys watching? Come on, pay attention, please. Angle 3 is the whole entire angle. You follow me? So I want to ask you something. I want to ask you, is angle 1 and angle 3, are they adjacent angles? I'll put just ADJ angles. And put a big question mark, okay? Are they adjacent angles? Well, first of all, they got to fulfill these 3 things, these 3 criteria. Do they have a common vertex? Let's take a look. Let's do this. Let's make this red. Here's angle 1. I'll make that red, right? And this big one right here is angle 3. Do they have a common vertex? Yes, they do. Do they have a common side? Yeah. Is it the one in the middle this time, though? They do share a common side, and that would be this one right here, wouldn't it? And in fact, I can make that red real quick like this. Okay? So look, they do share a common vertex, and they do share a common side. You see that? But what about the third one? Can they have a common interior point? Yeah, because watch. Right. But I was talking just about this particular situation, though. But now in this situation, look at angle 1. Forget angle 2 right now. Just look at 1 and 3. This point right here, it's in the interior of angle 1. See, this is angle 1 right here. And it's also where? In angle 3. So it is a common interior point. But in order to be adjacent angles, they can't be common interior points. They can't overlap. Exactly. That's a good phrase. Okay, they cannot overlap each other if they're going to be adjacent angles. You follow me? And that's basically what that's doing right here. What about 2 and 3? Are 2 and 3 adjacent angles?
No.
Same reason. All right, so they're not adjacent angles for that same exact reason. What about 1 and 2 right here? Yes, they are adjacent angles. All right, enough of that. We've covered adjacent angles. We do talk about adjacent angles a little bit later on. We don't talk a ton about it, so I think we've said plenty right now. Everybody good with that? All right, let's draw another situation. And here we go. Let's do another one.
Okay.
You've seen something like this before, and it doesn't have to be perfectly horizontal. All right, let's go like that. All right, you have 2 lines right here, but they are adjacent, aren't they? That's not what we're going to talk about today, or right now. We're not going to talk about being adjacent angles. More importantly, well, I don't know if it's important or not, but more specifically, these 2 angles right here form what? We talked about this yesterday or the day before. A straight angle. How many degrees is a straight angle? 180 degrees. That's right. So, again, lack of original thought here. I'll just make one angle 1 and the other one angle 2. Okay? Okay? So, I gotta stop saying that. So this is angle 1, this is angle 2, and they form 180 degrees. These 2 angles, if I said angle 1 plus angle 2 equal 180 degrees, you follow me? We call this situation a linear pair. Linear pair. And there's a good reason why they call it a linear pair. What geometry word is in the word linear?
Line.
A line. And pair means what? 2. So this is talking about 2 angles, not 3 or 4 or 5, just talking about 2 angles that form 180 degrees. And that form not just any 180 degrees, but a straight line. Okay, they can't just be 2 random angles that add up to 180. They have to be 2 angles that form one continuous straight line. Make sense? So that would be a linear pair. Again, we're going to use that vocab in another chapter. We're going to talk, and I'm going to say, okay, here's a linear pair. All right? How's all right? Is that better than okay? Verbal crutch. So there we go. That's a linear pair. Not that big of a deal. It's 2 angles that form a straight angle. Make sense? That's all there is to that. Let's draw another picture. Alright, let's do this one. Here we go. Just draw one like this, draw one like that, and that looks nice and pretty, doesn't it? Let's call this angle 1, let's call this angle 2, let's call this 3 and 4. Now, give me a good geometry word about what these two lines do. We don't know they're perpendicular. They intersect each other. We haven't talked about perpendicular yet, but we will at the end of this lesson. They're not perpendicular necessarily, but they do intersect each other. They intersect each other at this point, but they also form these four angles that I've drawn right here. Now, there's something special about two pair of these angles. Look at angle 1 and 2. Do you see how they're across from each other? Now, if I said 1 and 3, we just learned it like seconds ago. What would I call 1 and 3?
Adjacent.
Okay, they are adjacent. That's the first thing we learned today, but yeah, more specifically, they're a linear pair, aren't they? So 1 and 3, 1 and 4, 2 and 4, 2 and 3, you get the idea. Those are linear pair, they're adjacent. I'm talking this time about 1 and 2. Do you see how they're across from each other like this? We call these vertical angles. Somebody in the last class said, well, if 1 and 2 are vertical angles, are 3 and 4 are horizontal angles? And not a bad question, because you look at the vertical, it looks like they're up and down. But any angles that are across from each other, this whole situation could be all tilted a little bit. It doesn't have to be necessarily straight up and down. But we call these vertical angles. So let's list the two pair of vertical angles. Angle 1, and what's the other vertical angle with angle 1? The one that's across from it. Angle 2, good. And angle 3, and what's the angle that's across from angle 3? Angle 4. So those are vertical angles. You say, well, big deal. Who cares if they're across from each other? But check this out. I could show you a little mini proof on this, but I'm not going to just because of time's sake, because I know we have a lot more to do. Look at 1 and look at 2. Any ideas? What do you think? Yeah, exactly the same. Okay, and there is a way to show that they are the same. We'll hit that a little bit later, not today though. They are exactly the same. So 1 and 2 are equal to each other, and guess what about 3 and 4?
Same.
They're the same too. They're equal or congruent. In geometry, a lot of times we say congruent. I'm okay if you say that angles are equal to each other. Some geometry teachers may flip out and say, no, we don't say equal, we say congruent, but that's okay. 1 and 2 are equal, 3 and 4 are equal. So we can, that's always true on vertical angles. If you have two lines that intersect each other, they always form two pair of vertical angles. And the vertical angles are always equal to each other. No matter how we tilt these lines, the vertical angles will always be equal. Okay? They won't necessarily equal the same thing every single time. Like if this is 130 degrees, it doesn't mean every pair of vertical angles is 130 degrees. It just, right. But these two will always equal, and these two will always equal. Got it? So we could go beyond this, and that's actually, no, they don't write it. Eventually, I don't think in this chapter we're going to be talking about theorems and postulates and all these things. They're basically rules. And we have a rule that says vertical angles are equal, but right now we're just going to let you know that. We're not going to prove it or anything right now, so I'll just shorten this up. And a lot of times in geometry we shorten these up so I don't have to write out the whole entire word. So vertical angles are equal, or if you really want, we can say congruent. That's really important right there. We're going to use that a whole lot. Some of the stuff we don't touch on all that much. Vertical angles are equal, or vertical angles are congruent is something that we will hit quite a bit. You good with that?
Doesn't that mean that if you have one of the angles, you can find all four?
Exactly right. Let's do that. Let's say that, I don't know, what do you think that is? Like, let's say 40 degrees. Let's say that angle's 40 degrees. Then what's the easiest angle to find right now?
3.
Angle 3, which is what? 40 degrees. Now, if this is 40 degrees, remember, this is a linear pair, isn't it? This is angle 1, this is angle 4, it's a linear pair. If this is 40, what's angle 1 going to be? Be 140, right? Because take it away from 180, right? 180 minus 40 is 140. You could do it the same way here, or even this one. Look. Oh, I sure do. So this is 140 as well. Because why? Well, it's vertical with this, but it's also a linear pair with this one. All right, let's talk about some more stuff on the next video.